Have you ever stopped to ponder what exactly time is? A seemingly simple question, yet it unveils an enigma that has puzzled humanity for centuries. Time, an entity so integral to our lives, yet so elusive in its nature. From the ticking of a clock to the aging of our bodies, time shapes our existence in ways more profound than we often realize. So what is time? Is it merely an illusion, or is there more to it? Let's dive into the intriguing theories of two great minds, Einstein and Newton, as we try to unravel the mystery of time. First up, we have Sir Isaac Newton, the father of classical physics. A man of many talents, Newton gave us the laws of motion and universal gravitation, but he also contributed significantly to our understanding of time. He perceived time as an absolute entity. What does this mean? Well, in Newton's world, time is like a ticking clock, unchanging, unaffected by anything in the universe. It flows at the same rate for everyone, everywhere. It doesn't speed up, it doesn't slow down. It just is. Imagine a river that flows constantly, never changing its course or speed. That's how Newton saw time. It's a concept that is straightforward and intuitive. It's the way we experience time in our everyday lives, as a constant, steady progression. This idea of absolute time was the bedrock of Newtonian physics, shaping our understanding of the universe for centuries. For Newton, time was like an ever-flowing river, steady and unchanging. Next, we step into the world of Albert Einstein and his theory of relativity. Our journey takes us beyond Newton's static and absolute time to a universe where time is a dynamic and malleable entity, a concept that fundamentally reshaped our understanding of the universe. In the realm of Einstein, time is no longer a constant, but a variable that is subject to the influences of speed and gravity. Imagine you're aboard a spaceship, traveling at nearly the speed of light. Here, time would seem to slow down compared to someone stationary on Earth. This phenomenon, known as time dilation, is a cornerstone of Einstein's theory of special relativity. Now, let's add gravity to the mix. According to Einstein's general relativity, the stronger the gravitational field, the slower time passes. This means that a clock at sea level would tick slower than a clock atop a mountain. This effect, though minute on Earth, becomes significant near massive objects like black holes, where time virtually stands still. Einstein's view of time also painted a new picture of the universe, one where space and time are woven together in a four-dimensional fabric known as space-time. This fabric isn't rigid, it can bend and warp under the influence of mass and energy, giving rise to what we perceive as gravity. So, for Einstein, time was more like a flexible fabric that could stretch and warp. But what if time is not just a concept, but an object with physical size? This might sound like a radical departure from the norm, but it's an intriguing concept to consider. Traditionally, time has been perceived as an illusion, or at best, a backdrop against which the events of the universe unfold. However, this perspective puts time at the center stage, making it a tangible object that can be measured and quantified. Our understanding of time as an illusion is based on the classical theories of physics. However, the idea of time as a physical object challenges that view and invites us to reconsider the fundamental nature of time itself. This is not an easy task, as it requires us to move beyond our everyday experiences and intuition. The concept of time as an object with physical size suggests that time is not just an abstract concept, but something that has a physical presence in our universe. It's a notion that is still being explored and tested in labs around the world. But if proven, it could revolutionize our understanding of time and its role in the universe. This suggests that a moving, directional sense of time is fundamental to the evolution of life and the universe. So, what have we learned about time today? We started our journey with Newton's absolute time, a concept that saw time as a constant, unchanging entity, unaffected by the events of the universe. But then came Einstein, who turned this notion on its head with his theory of relativity, proposing that time is not absolute but relative, influenced by gravity and speed. We then delved into the intriguing idea of time as a physical object, challenging the traditional view of time as an elusive illusion. This assembly theory suggests a moving, directional sense of time is not just a backdrop, but fundamental to the evolution of life and the universe itself. From the laws of thermodynamics to the role of time in the evolution of life forms, we've seen how time is intricately woven into the fabric of our existence. As we continue to explore and understand time, we realize that it's not just a measure of our days, but a fundamental aspect of our universe.